Dr. Karel. He will do the presentation regarding the air monitoring of POPs by passive sampling as the indication of POPs contaminated sites, and he's our expert for the dioxin and furan analysis also. Dr. Karel?
Yes, do you hear me?
Yeah, sure. So you can share screen and you can start your presentation.
I just
Actually,
did it.
yeah, sorry that we have like overwhelmed discussion today, so that's why we have little bit delayed. So you can now.
No problem. We are learning from each other. No problem.
Okay. Thank you. Please
do
go
you
ahead.
See my screen?
No, not yet. Please share your screen. Yeah, now you can go for the presentation mode, I guess. Or if you're comfortable with this, no problem. You can go ahead. Yeah, now it's perfect. Super good. Yeah.
Oh, thank you. So hi everyone. Thank you for having me today. Today we're going to talk about the monitoring of POPs in air samples and also a small study that we carry out in an oil field regarding dioxins and furan in Kuwait. So as you know, the Article 16 of the convention requires that the effectiveness of the measures adopted by this convention to eliminate and to reduce POPs have to be evaluated regularly. To that regard, a global monitoring plan was established, and it aims at collecting comparable and reliable information on POPs levels in core matrices such as air, human tissues. We're talking about human breast, milk and blood, and also waters. All countries who signed this convention are obliged to initiate monitoring efforts to provide data that meet the requirements of the UN Global Monitoring Program. So in this regard, KISER is working on or has worked in different projects. Mainly, we developed a project EM066C led by Dr. Bondi, where we carry out a regional project when we send to different countries passive samplers to collect to know what are the levels of some POPs in atmospheric samples. So in addition, we have an ongoing project led by Dr. Bondi, by Dr. Hassan, regarding the assessment of POPs in human breast milk. This is project EM094C. And fortunately, just last month, we got the approval of a new project regarding blood. So it will be a potential association between the prevalence of non-communicable diseases and serum concentration of halogenated POPs in Kuwaiti population. This is led by me, and it will kick off on November 1st, so almost next week. So in this talk today, we are going to mainly focus on this the regional project I mentioned earlier. The primary goal of this project was to establish the atmospheric concentration of POPs across the Middle East and to understand the environmental processes that affect the sources and fate of these compounds. We also wanted to assess the spatial and temporal changes in the atmospheric concentrations, and to try to identify potential sources or hotspots for these compounds in the Middle East. We try to involve like the 12 countries that we serve in our regional center, but it really was kind of difficult. We even sent samplers to different countries that at the end, they did not reply to us. So finally, we got 5 countries participating in this project with 13 sampling sites, including Turkey, Lebanon, Saudi Arabia, Oman, and Kuwait. The samples, you can see the sample sites in this slide, and the samples were collected between January 2018 to October 2018. As expected, we have so many sites, like 5 different sites in Kuwait, because we can't deploy that many samplers. And in the other countries, we try to get as much as possible, also considering the funding that we have. And we included 2 sites in Al Rasil and Al Multaga in Oman. These 2 sites are very interesting because they are close to, one is hospital waste incinerator, and the other one is close to a metallurgic industry. So also Butal and Uludag in Turkey. And there is another interesting site, that is the American University of Beirut, that we have some interesting data coming from this location. Then unfortunately only 1 site in Jeddah, Saudi Arabia. In this project, we use both active and passive sampling techniques. So the active sampler were only deployed in Kuwait. So that's why we're going to focus on the passive samplers, because all the data that we have to be comparable, we're going to use the passive sampler for that. Normally, a passive, a typical high volume air sampling device consists of a high flow rate pump, 30 to 500 liters per minute. This pump is coupled to a glass fiber filter, and then we have a polyurethane foam, like we call puff, that we use to trap the organic phase, while the glass fiber filter trap the particle bound components.
Excuse me, Karel.
Yeah.
Can you just raise your voice, or I think maybe your mic is a little bit far, I guess.
Let me try. Yeah. So if we let's talk about then the passive samplers. These samplers are very convenient for this kind of study, because they can be deployed everywhere, because they do not require electrical power, and they are designed to sample by gaseous diffusion and absorption. So the sampler that we use in our studies consists of a polyurethane disc housed on a stainless steel container. These chambers are dampen wind speed effects, protecting the sample media from the deposition of coarse particles. These samples are also provide a time-integrated concentration of POP. This is different from the active sample, when we only deploy them normally for 24 hours, and we get from them kind of a snapshot of the concentration in this moment. But the passive samplers, we get an integrated concentration information about what's going on in this period of time, that is normally 3 months. So before sending the POF and the samplers to the different countries, we did we cleaned those POF, and we tagged them. We cleaned them according to the target analyze they were going to sample. For instance, we do acetone DCM for legacy POPs, then acetone toluene for dioxin, furans, and dioxylide PCBs, and acetone methanol for fluorinated chemicals. After that, the sample, these POPs were dry in a desiccator, packed, and labeled accordingly, even color labeled. But so we have no confusion. The people who are going to deploy this sample has no confusion to do their job. And then we send it, you can see this slide, to the different countries. So the sampling analysis was based on our internal SOPs. Like in previous presentations, you guys have presented all the instruments that we have in the lab. We also, a part of the instrument, we have to say that we also have the expertise to do this analysis. And we back in May, we got the ISO certification for the analysis of dioxin and furans and dioxylide PCBs in emissions and air samples. So after participating in different intercalibration exercises and we got this certification, so we are happy for that. So the general methodology for this kind of analysis, let's say about trace analysis of POPs, is, well, we collect the sample, we do the extraction in any type of extraction, chocolate, microwave, supercritical fluids, accelerated solvents extraction, any of these methods. Then we have a cleanup. It can be automated or manual, and then we go for the final determination. That could be GCMS, GCMS-MS, high resolution mass spectrometry, LCMS, any, you name it. So in our case, we took our samples. We inserted in a stainless steel cell. Then we spiked with the appropriate standard. In this case, in this example, is the EPA method 1613, or it can be the 1948 method for air samples. And then we do the extraction in the ASE Dionex accelerated solvent extractors, following the program that you guys see in this slide. After that, we got an extra that is not clean, so it need to be clean. And then I'm showing as an example the dioxin methods, where we use this automated solvent cleanup system, where we place the sample in a vial, and with the specific software program, it just do the cleanup for us. And we get this cleanup takes like 3 samples every 2 hours approximately. After that, we concentrate the sample, and we add the recovery standard. We are talking about we are doing the quantification by the isotopic dilution method. So we need an extraction standard at the beginning, and we need the recovery standard at the end to calculate and to correct possible losses during the analysis. I think you have seen this picture in the previous presentation. Anyway, this is our high resolution system where we used to do dioxylide PCBs, marker PCBs, dioxins mainly, and we keep the other analytes for the GCMS-MS or the GCMS system in our lab. Okay, so let's talk briefly about the results that we have that we got from these samples. Fortunately, we could do almost 1 year for all countries, and then we have a few more samples in the lab that have been finished now. So we will have the complete picture after, because the project was meant to cover 2 years of sampling. So the OCPs, let me show this first and then the other one. We cover a wide range of them, pentachlorobenzene, hexachlorobenzene, lindanes, the Hepex, cischlordane, transchlordane, oxychlordane, the DDTs and the sulfans. I mean, most of the PCBs and more that they are the ones that are listed in the Stockholm Convention, and the mean range that of the sum of these 24 OCPs was like I mean the highest concentration were found in Lebanon. You see the data. Then Turkey, Oman, and Kuwait, and finally Saudi Arabia. There are these sites in Lebanon where there are really high concentrations of lindanes. I think that we discussed with them some point in a previous workshop, and then they say that they have like a hotspot in the area where we collected these samples. So like you can see here, the para DDE was the most frequently detected compound with a frequency of 100%, followed by pentachlorobenzene, heptachlorobenzene alpha, lindane, then para DDE, etc. In the case of lindanes, as you know, the ratio between the two most abundant isomers is usually used to determine the source of these chemicals. In the technical formulation, the ratio between the alpha and the gamma is about 4 to 7. So in this specific project, the ratio that we found was Oman 141, Lebanon 020, Turkey 212, Kuwait 080, Saudi Arabia 082, while the ratio alpha gamma range between 0.1 to 3.6 for the whole data set, indicating that the sources of these lindanes across the Middle East may be from the historical use of it. Like I said, there was this high concentration of alpha lindane in Kartaba in Lebanon, and these concentrations were similarly to other report concentrations in agricultural sites. So maybe this is or they have a hotspot there, or this is an intensive agricultural site. So they are using this chemical. We don't know for sure. In the case of DDT, the relative abundance of parent and metabolite is used to distinguish age when this ratio is greater than 1 from fresh when this ratio is below 1. So in this study, the ratio orthopara DDT, para DDT ranged between 0.22 in Lebanon to 0.79 in Abdali, Kuwait, at all sites, indicating that the sources of DDT across the Middle East is from past or current use of DDT, probably in vector control. However, the ratio para DDE, para DDT in Al-Rasil, in Al-Multaga, in Oman, in Beirut, also in Ashray GF in Turkey, and Kartaba in Lebanon were less than 1, suggesting that the fresh usage of DDT is in the vicinity of these sampling locations. If we talk about PVDS, as you can see here, the concentration of this, the sum of PVDs that we analyzed in this study were uniform across the Middle East. while with value ranging from 4 picograms per cubic meters at Multaga site in Oman to 12 picograms per cubic meters in SCRC-KUWAIT site in Lebanon, included in this study, except for the relatively elevated concentration in Kuwait, where the mean and in annual ambient concentration across the country was 62. So I think Dr. Yasser before just spoke about that. The main, the highest concentration in this case were found in Sulaybiyah and Salmiya cities. Those are urban areas. And in the case of Kuwait and the other sampling points in Kuwait, they are remote areas or not pure urban areas. So the concentration in those sites were lower. If we talk about PCBs, we can say that the concentration were the highest in the samples collected from Kartava in Lebanon. Again, this site has some issues there, and the lowest in the samples collected in Abdal in Kuwait, that is, we can say a remote area, but they also have some oil activities going on there. The mean and range ambient PCB concentration on a country basis over a consecutive sampling campaign at multiple sites were as follows: Lebanon 254, Turkey 188, Oman 184, Kuwait 141, and Saudi Arabia 136. These concentrations were uniform across the Middle East countries included in this study, except for the elevated concentration in Lebanon. So let's talk about a little bit about dioxins and furans. So as you know, in the case of dioxins and furans, the concentration is given in toxicity values. In this case, femtogram ITEC per cubic meters. So these TQ values range between 4 and 30 femtograms, except for Kuwait and Oman, where elevated concentration 217 and 320 were measured. Typically, according to Lohman and Jones, the concentrations, the typical concentration, depending on the sampling location, is 10 femtograms for remote sites, rural areas 20 to 50, and urban and industrial area 100 to 400 femtograms ITEC per cubic meter. So if we talk about a little bit about, I don't want to enter in too much details on these profiles, but normally with these chemicals, there is like we call a fingerprint, where this profile indicates the source of these chemicals. So as you can see, there is different profiles indicate different sources. For instance, the homolog profiles in the samples collected from Kuwait and Jeddah were dominated by furans, comprising from 85 to 77%. In the case of Lebanon and Turkey, SCRC-KUWAIT and Kartava in Lebanon, they are broadly identical, but different from those collected at the campus of American University of Beirut. And these profiles were dominated by the octadioxin. And yeah, if we, you can see there that, for instance, these profiles are completely different. That the ones that are more similar are the ones from Jeddah and Kuwait, being different countries. But then if you go to Lebanon and you compare with Turkey or Oman, they are completely different, indicating that there are different sources in there. So this, finally, let me talk about this study that we conducted in 2014 to 2015 in an oil field. There are not so many information in the literature about this kind of studies. So, and we found something that is really interesting. You remember that I talked about this, the sources, the concentration for an industrial area is like from 100 to 400 femtograms, I think, per cubic meter. In this case, we found this 33 to 586, indicating that the activities related to the oil industry have an important impact on the level of these compounds in ambient air. On the contrary, the concentration of dioxin-like PCBs were really low. So up to 36.8 HUTEC per cubic meters. That is suggests that there is no local source in these oil fields. The concentrations of dioxins and dioxin-like PCBs were not controlled by temperature variation, resulting in the absence of any observed seasonal pattern. A unique dioxin profile was found in ambient airs collected from this oil field, and we have to investigate further to check if this profile belongs to the desulfurization facility located or from flaring oil drilling. But as you guys know, it's not easy to go inside these oil fields. So finally, I want to acknowledge our KFAS, our funding agency for funding project EM060AC, the regional organization for the protection of marine environment, RODME, that also made a contribution, a financial contribution to this project. The Kuwait oil company for funding the project as EC086C. That's the project related to this last study I showed before, and the government initiative that help us to establish and develop this state-of-the-art lab that we have at this moment in Giza. Thank you for your attention.
Okay, thank you, Dr. Karel. So I'm welcoming the floor for the. Yes, please go ahead. Mazen. So if anybody has a question, please do a quick chat. Now the floor is open for the discussion.
Yeah, Karel, thank you very much. And I think what is really nice is that you know the levels at what concentration, for example, in dioxin in air, you consider somewhere a relevant emission source. Do you also have for the PCB concentration level in air, where you would say, this is a background level, this is normal urban, and at that level, it seems rather somewhere contaminated sites?
Yeah, I mean, when we went for urban areas, the concentration of PCBs were higher than in industrial areas. So, for instance, in the case of this study I showed before on the oil field, there was a really different concentration in these two families. On the other hand, we also measure different PCBs, non-dioxin-like PCBs, and the concentrations are pretty average. So when we compare this concentration with the ones reported by other authors, so they are like normal levels. They are not high level, except this site in Lebanon that I would like to insist on collecting
more data.
More data about this site to see what's going on. According to them, they know they have some problem there. They have like a hotspot. Maybe they have some storage of these chemicals there. But in all different target analytes, the concentration in this spot was high.
Yeah, because I mean, then with the passive sampler, for example, if Iraq at the moment does not know which of the sites are contaminated, so there could be a possibility to install, I don't know, 20, 30 of these passive samplers. And then after, I don't know, 1 month or so could be gathered. And from these data, you could then, let's say, give direction if this area could be PCB contaminated or rather not.
Yeah, that's a possibility. Then we have to discuss the logistic of all of this from our side, and I know from Dr. Hassan's side, we have no issues, but then we have some issues to discuss with in our center too, because I mean, from me, we should cooperate more. We should be more related, and we should work more together. So, but then at the same time, then there are some logistic issues that sometimes prevent us to do this work as a regional center and having this analytical capacity. We should be able to. I don't know if it can be done through regional projects. I don't know if UNEP can help to fund all these issues, but at the end of the day, this is, from my point of view, this is one of our main goals to help our countries that we serve, and I'm really wanted to do this because there is no data in this region.
Okay. Yeah, good. Yes, I mean, we know that UNEP has some funding to support. And for Bahrain, I think we have already sampled soils. Yeah. But I mean, the approach is, I mean, when we talk about PCB contaminated site, if not one passive sampler in the middle of such a site, to understand if there is somewhere a PCB source might be the most simple one first, before taking soils.
Dr. Roland, there is no need for funding for this thing. These 4 or 5 samples, that's okay. We're going to do it with my project. I will include it in my project. I'm sure Dr. Hassan will also help with his project. There's no issue for that. But if we are talking about the regional scale, when we want to bring in a sample from Bahrain, and I spoke to them and send the samples, we will do it. So then Iraq, then we have some other countries. So we need to have a structure for that. We cannot receive samples and then we cannot analyze them. We have a lot of samples from Oman also in the lab that we haven't analyzed yet. We don't have the structure for that. So that's what I'm saying. So I'm sure that Dr. Hassan agrees with me. And yeah, we have the capacity, we have the people, but we don't have the structure. That's what I'm trying to say.
Yeah. No. So therefore, I brought, let's say, KISER and UNEP regional office together. So there is already exchange. I mean, you with UNEP and also Dr. Hassan with UNEP. So the question is then now for the regional project, maybe the KISER need to think, you know, before Bondi developed such a regional project. Yeah, but of course, it would be great if Dr. Hassan could do something similar. Yeah, I mean the KISER team. I don't know if Dr. Hassan is online.
Yeah, Roland. Actually, Roland, I discussed with Karel to continue with the air, continue of Bondi work as a regional project. So because they're already the best sampler allocated. By the way, I pushed Iraq to have a site. Unfortunately, we couldn't. Ammar, you know that. I pushed Ammar several times that we have regional project and you can use that project to get a result in case in the future if you get NIB, you will have a data. Unfortunately, they couldn't take any passive sampler. I suggest to Karel, we said several times, why you not continue with this regional what have done by Bondi, you can continue with this. And my suggestion also, because milk is one of the team of the convention, Stockholm Convention, so probably after my project, and probably with Iraq project, probably will be a regional project also. I feel that if we continue with air and with another team of like milk, we will be succeed to give this country all the technical assistance and all the data they know they needed. So let's see in the future how will be how the cooperation with other countries.